the first thing that I want to do is I want to just kind of lay out some core concepts and goals for our session. So the goals for the session are that we're going to learn the roles that shaders and materials play in rendering in Unity. We're going to learn how to create a custom refractive transparent shader for our game, and we're going to learn how to add time-based rippling distortion effects to our custom shader. So it's going to kind of move and ripple over time. So let's talk about what is a shader. A shader is a computer program that's used to do shading during the rendering process. The production of appropriate levels of light, darkness, and color within an image, or in the modern era, also to produce special effects or do video post-processing like image effects. A shader is a program specifically made to run on a GPU and is ultimately what draws the triangles of your 3D models in 3D rendering. Shaders are traditionally written as text-based code. In this lesson, we're going to look at a graphical node-based tool, Amplify Shader Editor, but as mentioned, there are other ones as well, which will allow us to create shaders without typing CG, which is short for Central Graphics, or HLSL, which is short for High-Level Shading Language Code, right? So typically, people might type in the code for their shaders. We're going to be using a visual tool which will allow us to author shaders. So let's talk about how rendering actually happens in Unity. So there's a couple of pieces we need to render something in 3D in Unity. We need a 3D model which contains vertices, vertex colors, UV data, and normals. The model has a mesh renderer and a mesh filter, and the mesh renderer has a material assigned. The material uses a shader and has textures, colors, and generally speaking, property values. And we're going to look at what those are. It may have those things, right? Shaders can have all kinds of different properties. The shader uses the data from the 3D model and from the material to draw pixels to the screen based on its CG or HLSL code. And so I took a diagram here from Alan Zucconi's excellent and short A Gentle Introduction to Shaders article, which you can find at the URL on your screen. And it's a nice place if you want to kind of get, as the title says, a gentle introduction to shaders. And so shaders, the way that shaders relate to materials is that a material uses a shader to determine how it will be rendered. So materials contain values for shader properties. For example, in our diagram here, this is a snapshot of a standard shader, a material that uses the standard shader. We have things like the albedo texture or the albedo color or a smoothness, which is a float value, right? Importantly, multiple different materials can use the same shader with different properties, right? So if you've worked in Unity before and created materials, the default now when you create a material is to use the standard shader, which looks like the inspector that you see here, right? But you can make the standard shader look all kinds of different ways by passing in different texture maps or normal maps or emission maps or colors. And those are all the properties of the shader, right? So the code of the shader doesn't actually change, just the properties of the shader. So one way to think about this, and this is an analogy, right? This is not literally true, but shader properties can be thought of as having a similar use to the public variables of a script in Unity. We can have two instances of a C# script attached to different objects with different values set in the inspector, as an example, right? That's not literally the case, but let's say you could have two enemies. They both have the same health script with the same code, but one has 10 hit points and the other has 20, right? So here we have the same shader code, but we're passing in different colors or different textures to render our object. So let's take a look at our actual, I'm going to turn off my audio for a second. Let's take a look at this material that we're working with. So I'm going to enter play mode, and I'm going to enter my invisibility mode and then pause. and we're going to pull up the object with the material. So the object is a child of our pistol. It's the shooter FPS weapon, and it currently has this shooter FPS weapon invisible material assigned to it. And here it is in the project. So when we look at this, and so what's happening with this mechanic, and if you were here for our last session, you saw us set this up, we're switching between this standard shader material, right, which causes our arm to look the way it does when it starts, right, and has an albedo map and a metallic map and an emission map. And then we're switching over to our invisible material, which uses our custom shader, our invisible shader. And you can see that up here in the shader field. And so the invisible shader has a couple of values. It's got a ripple scale value, a disturbance scale, ripple speed, how fast the ripples are going to scroll or change, and a blending value, which we're using to go back and forth to white. So let's take a look. And it also has a property for a distortion map, and we're using this small waves normal map texture. So if we go, let's go out of maximize. If we go into play mode and we adjust, for example, the ripple scale, we can see we can have these very small ripples. I just have to push R to keep switching it back into. We can have the scale of the disturbance, right? We can have 0, which just makes it totally clear, or a little bit. And then what you see fading to white is this blend amount here. So with the disturbance scale, so we're automating that blending. So we can also change the ripple speed, right? Have it scroll really fast. Looks kind of crazy. And so these are all properties of the shader. And you're going to see us set this up as we create this custom shader, along with the distortion map, which is a texture that we can assign. So we're using all these properties, and we could, for example, if we wanted to have like a fast ripple and a slow ripple instance of this material, we could copy the material, change these settings without changing the actual shader, and then have two different materials with different appearances, right? Or with different rendering properties. Okay, so that kind of lays out our basics, right? We've got some core concepts. We've looked at our shader that we're going to build in the inspector and seen what it can do. And the next thing that we're going to do is actually dive into Amplify Shader Editor and start creating a new shader from scratch. Okay, somebody's asking about how to make lava. You know, you could actually use some of the techniques we're doing here to make lava, the scrolling and stuff and emission stuff you could totally do with this. Somebody's recommending for lava to check out catlikecoding.com. Jasper Flick, his tutorials. Generally, I really like his tutorials, especially if you prefer written tutorials. He does some great stuff, so I wholeheartedly recommend his stuff.